Good morning, everyone. My name is Brendan Horan. I'm a Grassland Systems Research Officer with Teagasc. On my left is David Wall and Donal O'Brien, experts in emissions and soils from the Johnstown Castle Soils and Land Use Department. Our message for you this morning is that in terms of future systems, where we combine best practice systems and the latest available technology, we can achieve our goals in terms of growing sustainably as a dairy industry, meet our national and European climate commitments, and based on that, the best days of the dairy industry are actually in front of us. Okay, and we want to elaborate on what we mean in terms of that. So we're going to begin by defining what we mean by growing sustainably, because that's really, really important. There's a lot of talk about emissions right now, but it's a bigger overall picture. When we talk about growing sustainably, we're talking about agriculture as part of an overall food system, where customers are really interested in how food is produced, and what happens on our dairy farms is significantly important in terms of that overall food story. Okay? In terms of the characteristics of systems that grow sustainably, they have to be profitable, family farms that can grow and invest in the future and adapt to changing situations. It has to be environmentally benign. It can't lead to a reduction in terms of our environmental standards, can't lead to damage to the natural environment. We're talking about producing food in a way today that doesn't affect the ability of future generations to produce food in an equally sustainable way. We're talking about high quality products and produced in a way on farm that leads to high welfare status for both the people running these farms and also the animals employed in them. So that's our definition of sustainability. Now you might say to me, well, we're doing this already. We don't need to do any more. Well, that's true to some extent, but there's a compelling case for why you should adopt the latest technologies and improve further in terms of the sustainability of your dairy system. Okay? The reasons for that are, number one, it will make the farm more profitable and give you more opportunities in terms of adapting to the future requirements as a dairy farmer. Number two, we have made significant commitments nationally and in terms of the EU in terms of not just emissions, but also in terms of water quality and in terms of biodiversity. And, agriculture is a significant pressure in each of those areas, and we need to identify solutions and management practices that allow us to be good in all areas, in each of these areas. Okay? Because customers care. Okay? And as a large exporting dairy industry, 90% export based, we need to care and be able to communicate with our customers and differentiate ourselves from any other dairy industry in terms of how we produce milk. And we are unique and we can do that. I suppose in terms of the on-farm story, Irish dairy farms and Irish agriculture in general is significantly important. It's responsible for about a third of total emissions nationally. Okay? We're expanding, so we need to be very careful that as we expand, we grow in a sustainable way so we don't lead to increased contributions. I suppose in terms of doing that, there's 2 points to make. Number one, Irish agriculture is not particularly intensive. We're midway in the EU. And if you compare ourselves with the big dairy production nations in mainland Europe, Irish agriculture is actually semi-extensive relative to those industries. Okay? And in terms of our emissions profile, it's among the lowest in the EU. So we are doing this quite well, but we can even do it better in the future. In terms of achieving that then, what's involved? So for us, we've broken that into 3 parts. The first part is we need to do the basics really well. Just like anything, doing the basics really well is an essential part of this. We're not going to deal with these in detail today, but we do want to mention them. On-farm infrastructure. Having adequate on-farm infrastructure to store and utilize nutrients efficiently on our farms is essential. Okay? Excellence in terms of nutrient management planning. Using appropriate rates of nutrients at the right times, in the right forms, that's crucial. And so building a system around efficient nutrient management and good soil fertility. Okay, and the last one in terms of grazing. Grazing is centrally important to everything we talk about today. So in terms of improved grazing management practice, that is underpinning everything in terms of productivity from a grazing system and our overall sustainability objectives. We're not going to deal with those in details. They're going to be covered later in the day, but we're ticking that box and saying that every farmer here is working on all of those to improve them today as a basis for the systems we need in the future. In the second part, we're going to talk about, some of the parameters in terms of future systems and what they might look like. The first thing, and Padraig has already covered it, future systems will be more profitable where we integrate good grazing management practices in these systems and better technology for the future. It's very much going to be based on more efficient ruminants than we have today. In particular, from the sustainability part, it's about ruminants that last longer on our farms. So going from that 3.4 lactations per cow on average that we are at today to 4.5 lactations in the future, reducing the requirement for replacement animals. That's going to be a massive part of the overall story in terms of the sustainability of our systems. Equally though, we need animals that are capable of very high levels of productivity from a grass-based resource. So really efficient at converting pasture into milk solids. In terms of pasture, it's based on high objective targets in terms of pasture utilisation. Again, you're going to hear a lot more about that later in the day. And in terms of nutrient use, it's going to be based on no more nutrient use in terms of external nutrient imports than we are using today. And indeed, on many farms, we expect to see a reduction in nutrient use in the future. Clover has become significantly important in our systems now. Integrating it and using it to replace chemical fertilisers is part of our objectives, and that will allow us to reduce chemical fertiliser in the future, and that's something we're aiming for. In terms of the sustainability credentials then of these future systems and how it compares with where we are today, the nutrient surplus, the amount of nutrients going in over and above what's coming out in product from our systems, will be no greater in the future than it is today. So no risk in terms of water resources or in terms of nutrient use. And it will result in significant increases in nutrient use efficiency. That's built into the climate action plan that was launched about 2 or 3 weeks ago now, that improved nutrient efficiency in agriculture is really, really important. This is the basis for it. In terms of ammonia emissions, an area where we face fines if we don't improve, the average dairy farmer in these intensive systems will have the same per hectare effect, that we can significantly reduce ammonia emissions from our systems over and above the most intensive dairy farmers today by virtue of the technologies we're talking about. And in terms of total greenhouse gas emissions, in terms of greenhouse gas emissions per hectare, we're good today and we can improve further, reducing that to maybe 0.7 of a kilo of CO2 per kilo of product in the future. But in terms of total per hectare, which has been increasing, our most intensive dairy farms will actually reduce per hectare by virtue of embracing the technologies that we're talking about. So I suppose in terms of the total contribution to this system, it will be no bigger than the average dairy farm today in the future, while being much more profitable and much more productive. In terms of the technologies, the key technologies to do that, David is going to talk to you about the science behind those technologies right now.
Okay, thanks Brendan. So Brendan has outlined the system, the future system, how we're going to achieve that. So in terms of the technology, we've been looking at a range of technologies over the last number of years, how these technologies integrate in the system, and what we've identified is 7 key technologies that future farms of the future, dairy farms of the future, will need to implement. So the first one of these is white clover. Incorporation of more white clover in the sward. Why do we incorporate white clover? That's going to give us a potential reduction in chemical nitrogen input. That's the key there. Achieving increased nitrogen use efficiency is going to be key in terms of achieving both agronomic and environmental targets into the future. In terms of the benefits here, we can get up to 7 to 10% increase in terms of milk solids, so better for your business overall. In terms of 10% reduction in carbon footprint, that's the key in terms of meeting the greenhouse gas targets. And overall, the bottom line, what you have in your pocket, is going to be the key. So you have a potential increase there of up to €150 by reducing the nitrogen fertiliser, increasing the quality of the milk. Overall, this system really does work, right? The next one here is holistic slurry management. If we think about slurry is a key resource that you have on every farm, and using that more efficiently is going to give you multiple benefits overall. So the 3 quick key questions that we need to ask ourselves in terms of slurry management, right, is where do I put it, when do I spread it, and how do I spread it? Those are the 3 key questions. The first one is, where do I put it? We need to either return it to the silage ground where that slurry came from, so the silage that you fed over the winter, or we need to put it on the paddocks that have the biggest P and K requirement, because the most value of the slurry is in the P and K. The next question then is to do with nitrogen and nitrogen use efficiency. So by spreading in the spring, you're going to get more value from your slurry compared with spreading it on a day like today, where a lot of the slurry in is going to go up. And then the final bit of this is, why are we going to go to a low emission slurry spreading? And that's because of the last question. So if we're spreading on a day like today, the sun is splitting the stones, we have a low grass cover, we're going to get most of the nitrogen moving up into the air, volatilised, and that's going to lead to increased ammonia emissions. So by moving to a low emission slurry spreading technique, so like a trail and chew, we're going to get multiple benefits, and you'll see that later as you go up to the slurry demo later on. In terms of numbers, if you want to put numbers on it, you can see here, even with the splash plate, by spreading in the spring, you get much more value in terms of total N. However, if we move to a trail and shoe type machine, we can move all the way from 15 kilos of recovered N, or 15% recovered N, right up to 40%. So it makes sense. The next one here is protected urea. Why protected urea? Protected urea is going to give us a multiple benefit in terms of both greenhouse gas and in terms of ammonia emissions. So we get a 73% reduction in terms of greenhouse gases and a 78% reduction in ammonia compared with straight urea. Is there an impact in terms of moving to a straight protected urea type product? The answer to that is no. Right, so we've looked at it at 150 comparisons. We have it here on the farm here in Moorepark. We have it in Johnstown Castle, where it's integrated into the dairy system. We see no yield penalty, and if anything, we actually see an increased nitrogen recovery from protected urea. So while there might be no direct yield benefit, there's benefits there in terms of the price of the product and also in terms of the environment. The last three then, in summary, in terms of keeping our concentrate feeding level at a minimum, right? So utilising more grass, cutting back in terms of concentrate feed input, and also then looking at the crude protein through the grazing season. So we don't need to be feeding a very high crude protein ration. The grass already has a high crude protein, greater than 18% most of the time during the year. So we can cut back somewhere between 12 and 14% crude protein, reduce the nitrogen excretion coming out the back end and the potential losses from the system. Protecting biodiversity is going to be key in terms of our image, as Brendan has outlined. We currently have in our grassland system a high level of biodiversity already, but that can be enhanced further. We can get up to that target 10% by protecting habitats on the farms and also managing our hedgerows, etc. Incorporating clover as well will give you a benefit there. Energy and water efficiency, we all can see electricity costs are going up. So there's benefits there in terms of milk pumps, plate coolers, photovoltaic, and there's grants there, and you can find out more information as you go around later on. In terms of water use efficiency, recycling water for washdown, using leak detection in terms of meters, water meters, etc. We need to get to grips with our water use on dairy farms and reap the benefits there. Anybody that's on a meter already is paying for it. Right, in terms of the final piece of the puzzle then is the asset program has been out there to help support you as farmers to increase your water quality and minimise the effects on water quality in your area. You're living in these rural local areas. Most of you have wells, so you're probably drinking the water. So it's in your own interest in terms of protecting it. The asset there can go out, help on your farm in terms of identify potential issues that can be solved over time. That also protects you in terms of future inspections, etc. So in summary, if we were to summarise this, growing sustainably is achievable, and it can lead to more profit and more efficiency on your farm. So it is achievable. However, these key technologies are going to be key in the future on your farm, right? So what will that give you in terms of what we must rely on in the future? Appropriate farm infrastructure. That means in terms of slurry storage, farm roadways, etc., to help you manage the animals in a sustainable way for welfare, but also in terms of labour, etc. We need efficient cows, so the EBI system has worked well going forward. There's always room for improvement on farms, and if we can get the lactations, number of lactations up, that means then the system is going to grow more sustainably over time. Other things there in terms of soil fertility, nutrient management, they're going to be key into the future in terms of growing more grass and then utilising more grass. In terms of appropriate stocking rate, so whatever your grass growth is, if you don't know it now, you need to go out and find out what it is and then match your stocking rate to that grass growth level. There's no point in having a stocking rate that is above and beyond what you're growing. you're then back into a system of feeding more concentrates and impacting on your bottom line. So match your stocking rate to your grass growth. And then finally, the use of protected urea and low emission slurry spreading are going to be two key technologies in terms of achieving both our ammonia targets and our greenhouse gas targets in the future. But these technologies lead to better agronomic performance, give you opportunities to reduce your fertiliser bill. So in summary, look at the best years of the dairy industry are in front of us. This is achievable, but we're going to have to make some tweaks to the system and get more efficient.
Folks, we're going to take your questions. Can you put your hands up and we'll try and take any questions? Yeah. Repeat the question.
Okay, so
Repeat
the question is to do with protected urea and in terms of the breakdown of the product in storage. So basically the protected urea can be stored, it can be bagged. Usually urea comes in the back end of the year before, it's bagged, and then you use it over the following growing season. Depending on the product, we use a dry product here. That dry product is coated onto the granule. It can be, in terms of another type of the same product, it can be put into the melt in the urea. So either or work effectively. It has a shelf life probably of a year, to be honest. So, you know, stuff that's bagged in November, you're going to be using it before September, so there's no real problem there. In terms of efficacy, the levels that are being dressed on the Irish product are small, so they're small overall. However, there's room for manoeuvre. There's a little bit of insurance in there in terms of what's on the coated onto the granule. So essentially, from all the research work that we've done, it's effective whether it's used within the year after bagging. So I don't see any problem in terms of the product.
Other questions, folks? Yeah.
Yeah, so in terms of protected urea, yeah, so the question is, can we use protected urea all year round? In a nutshell, yes. So basically what the protected urea does is it protects the urea granule in dry weather. Typically, we always use urea in the spring when the soil is damp or when there's plenty of moisture. The protected urea acts similar to CAN mid-season. So we've got same yields as CAN. We've got slightly higher recovery at times. And compared with a straight urea product, which nobody's using mid-season, it's much more efficient. So the answer is yes. Yes, so the protected urea, so the question again, is it possible to get an NS, so a sulfur with the urea? Yes, there's a 38% N and 5% sulfur product that's out there, so perfect for top dressing in terms of silage, etc.
Further questions? Is there white clover in that sward? Is there white clover in the sward we're looking at? There isn't a lot of clover in that sward today. I can't say whether it was sown in that sward or not. In general, on dairy farms, the level of white clover is pretty low today, but that's, I suppose, the science that we have. And we have a lot of, as you go down through the farm and into demonstrations, you're going to see high proportions of white clover in some of the swards. And the science shows that it's really valuable. And if it's not there today, it's going to be there in the future.